Alright, now in the previous lecture we have learned how can we delete a node from CircularDoublyLinkedList. And we have learned that we have three cases for deletion of a node from CircularDoublyLinkedList. So these are, we can delete a node from the beginning of CircularDouble. So we can delete the first node from CircularDoublyLinkedList. We can delete a node at any given location from CircularDoublyLinkedList, and we can delete a node from the end of CircularDoublyLinkedList, which is last node. Now in this lecture we are going to combine all these three cases in one algorithm to see the big picture of deletion, and based on this algorithm in the next lecture we are going to deletion of a node from the CircularLinkedList in practice. Now let's see our algorithm. Now our algorithm starts with the location parameter. Now based on this location parameter we are going to identify from which location we want to delete a node from CircularDoublyLinkedList. Now the next step is we are going to check that if head is equal to null or not. So if head is equal to null, it means that our CircularDoublyLinkedList does not exist, so we can terminate our algorithm. Then we are going to continue. If head is not null, then we are going to continue to check location parameter. So the first thing that we are going to check if the location parameter is equal to first or not. So if the location parameter is equal to first, it means that we want to delete a node from the beginning of CircularDoublyLinkedList. So this means that we want to delete first node. Now when we are deleting first node, we have two cases. The first case is in which we have only one node in our CircularDoublyLinkedList, and the second case is we have more than one node in our CircularDoublyLinkedList. Now if we have one node in our CircularDoublyLinkedList, the steps are like this. So we have to set previous and next reference of this node to null, and we have to set head and tail to null. And with these 4 lines of code, we are deleting the links that comes to this node, and this node becomes eligible for garbage collection. So garbage collector can come and delete the node from the CircularDoublyLinkedList. Now the next case is in which we have more than one node in our CircularDoublyLinkedList. Now if we are deleting first node from the CircularDoublyLinkedList, this means that head has to point the node that comes after this node, and previous reference of next node has to point to last node, and last node's next reference has to point to this node. So here I'm going to set head to head next. So this means that in head.next we have second node's reference. So if I set to head, we are creating a link between head to second node, and a link between head to first node gets destroyed. Then in head we have second node's reference. So if we set head.previous to tail, we are creating reverse link from second node to the last node. Then at the end, last node's next reference has to point to this node, which is second node. So this means that I'm going to set tail.next to head. And with this, we have successfully deleted the links that comes to the first node, and first node becomes eligible for garbage collection. So garbage collector comes and deletes this one from the memory. Now after doing these operations, we can terminate our algorithm. Now the next case is if the location is not equal to first, we are going to check that if it is equal to last. So if it is equal to last, in this case, we are going to delete last node from the CircularDoublyLinkedList. Now when we are deleting last node from CircularDoublyLinkedList, in this case also we have two cases. Now the first case is we have only one element in our CircularDoublyLinkedList, and the second case is we have more than one element in our CircularDoublyLinkedList. Now when we have one element in our CircularDoublyLinkedList, the deletion is same as when we are deleting a node from the beginning of CircularDoublyLinkedList, because this node is the last node and the first node in our CircularDoublyLinkedList. So here all we have to do, we have to delete all links in this case. So we are going to set this node's previous and next references to null, and head and tail to null. And with this node becomes eligible for garbage collection, and garbage collector deletes this one from the memory. Now the next case is we have more than one element in our CircularDoublyLinkedList. Now when we are deleting a node from the end of CircularDoublyLinkedList, the first thing that we are going to do, we have to change tail reference to point to second last node in our CircularDoublyLinkedList. Now we know that in the last node's previous reference we have second last node's physical location. So if I set this reference to tail, it's going to create a link from tail to the second last node in CircularDoublyLinkedList, and a link between tail and the current last node will be deleted. Then we have to update the next reference of second last node to point to the first node. So in this case, after this update in tail, I have second last node's physical location. So if I access tail.next and set it to head, with this we are creating a link between second last node and first node. Then I have to update the first node's previous reference to point to the new tail. So in this case, I'm going to update it head previous to dot tail. And with this, a link between first node and the current last node gets destroyed, and the last node becomes eligible for garbage collection. So garbage collector comes and deletes this, and after deletion we are terminating our algorithm. Now the last case is if the location is not equal to first and if the location is not equal to last. So in this case we want to delete a node from the specified location. So here all we have to do, we have to loop through the CircularDoublyLinkedList until we reach the location -1. Now when we reach the location -1, we are going to delete the node that locates after the current node. So in this case we have to create a link between current node and the node that comes after the next node. So that's why I'm setting current node's next reference to the current node.next and .next. So with this current node.next we are accessing next node, and if I put one more next over here, we are accessing the node that is located after the next node. Then I'm going to update the node that is located after the next node's previous reference to point to the current node. So with this we can successfully implement this logic over here. So we are setting current node.next.previous to the current node. So with this we are creating a reverse link from the node that comes after the next node with current node. Now after doing so, we have successfully deleted the links that comes to the next node. So the next node becomes eligible for garbage collection. So garbage collector successfully deletes this one from the memory. Now then we are terminating our algorithm over here. Now with this we have come to the end of this lecture. So in this lecture I have combined together all three cases of deletion in one algorithm. Now based on this algorithm we are going to implement deletion of a node from CircularDoublyLinkedList in practice. So see you in the next lecture.